Hi everyone. Today I want to share some the Golang performance of the optimization on sorry. How to use it? Okay, today I want to share the topic about the Go performance optimization. So I already working on Go for about more than 3 years. Yeah, and before I came to Singapore now, working on the Zalora. I'm working on the mobile API team, and also for our web. We create the API application so for mobile and web. And so now already before coming to Singapore, I work in China and also working on the CDN system, writing the Go. So all my experience is working with Go. So today I want to share this topic with you. How many guys have learned the Go? Use the Go in your application? Okay, so this is our outline. So first I will introduce the string join. So then I will introduce the profiling, and then I will introduce the slice and the array and the map, which is with the high performance. And at last I will introduce the HTTP profile. And the first, just Andrew, you have the PPT, you write the little array, but actually it's not an array, it's a slice. So it's different. Much difference. So first I want to introduce the string join. So in the Go, if you want to join two strings, we have four methods. The first one is the press. The second one is the FMT, the standard library, and the third one is the strings join, and the last is the bytes the buffer. So which has the high performance? So let's have. If you don't know which has the high performance, just use the Go's benchmark, because inside the Go they already have a inside the package testing. So you can write the benchmark function easily, and then you can test it, which is have the high performance. So now the first one I will compare the FMT package with vs the press. So let's see this code. We define two strings, and then this is the bench for the FMT. This is the bench for the press. So from this result, we can know the press have the high performance. So this is the benchmark function. So it starts with the benchmark, and then have your own function name. And the param is B. This is inside the testing package, the benchmark. It will learn. So how do we know this is B pointed N? How do we know the N number? So inside the Go, it will learn learn 10 loops, and then he will calculate the time, and then he will assign this N to a small number or a big number. So you can see this is a different number. So it's depend on this the first 10 loops, and then he will decide which your benchmark is better or poor. Like this. So from this result, I will show you this code. This is the join FMT plus test go. So this is our code. So the result, I can use this go test bench. So FMT plus test. So to learning the benchmark. So based on this result, we can see the bench press he learned about 10 million times, and the FMT prep is learned about 1 million. So and based on this, every options it hosts 106. So from this result we can know if it's easy join, we can just use the press. It's much high. It has the much has a good performance. Okay, let's. So the press vs the FMT. The press has the better performance. Next time. Okay. So we can if our string have many types, like the string have the string type and also have the int and the int 44, and then based on this result, we can based on this result also the press have the better performance, but we use the string converter package to convert this type into the string, and but we still use the press to join the strings. Also, press 2. So still based on this result, the press is still have the better performance. So for the different type, also we can use the press. It also has the better performance. Next, so based on this, next so the press have the better performance. Now we do the compare with the strings join with the press. So this is our press function. So we pass in a string slice, and this is a separate, and then we join these strings and then return the string result. While we use the strings join, just to use this easy function. So also we define this string and define a string slice. And this is our bench function. This is the bench join, and this join call this join function, and call this press function. So based on this result, we can see the join function have the better performance than the press. Let's see this one. So based on this result, we can see the join function have the better performance than the press. So let's go on. Next, we will compare the strings join with the bytes package. In the BAF, this is our BAF function. This is our string point join function. In the BAF function, we use the bytes BAF, and then write all the bytes into the string, and then return this result. Based on this result, we can see the strings join has the better performance. So let's see this result. So this is join is better than the buffer, but still we have this. If we want to return the bytes, we don't want to return the strings, because the string and the bytes will convert every time. Inside the Go, if you the string and the bytes convert, it's a value copy. So it will copy this value into another variable, and increase your memory. So I just want to return the bytes. So let's see this result. This is our calling this join the path. We can see the result is closed. Let's see. To compare this first one, I think this is much better than the first one, but well, we still see the buffer is poor in the performance, but I like the buffer. So how can I? Because I like the buffer. Can we make it much fast? So we can use this Go test bench, and then we can use this. Inside the Go have the tool. You can profile this the result. So we can learn our benchmark and output the CPU profile to the file CPU block file. Let's see this result. So this means that I want to learn this test, and then learn the bench, and I will also learn this CPU profile to output this CPU profile to this to the CPU dot profile, and then learn this file test file. So when learn this benchmark, it will output this profile in this file in the CPU dot file. So we can see this; it's already output this file, and then we based on this file we can use this use the Go tool to profile our program. So use the Go tool profile. This is the test point test. This is the output. When we learn this command, actually it will compile this file into a binary file, and then based on this binary file, it will output the CPU profile to this file, and then we can use this command Go tool profile, and this is our binary file. This is our output profile. So we can use this one, and then we can talk. This is our based on this. When learn the benchmark, it will sorry, I don't know how to say it. it will record all the CPU point when the minor microsecond. Every millisecond, the CPU is learn which function. So he will record this result. So based on this result, we can see about much time is on this function, learn time, sigma. So I think this is based on because when you copy, convert the string to the bytes, and then bytes converted to string, the memory will copy and copy, and then because the benchmark is like our load learner is learn this, and so based on this result, also okay, we can. So we can use this wrapper, and it will output the profile result based on this profile. So you can from this SVG, and you can see this is our bench, and then this is learn, and about 436 is learn this function join, and we can based on this result, and according to this law, we can see which function is learned most times. So based on this diagram, we can easily find the high point in which function. So it's easy for us to debug our program's performance. So use this, and next time, later I will introduce the HTTP profile. It's like this. So we can see our most time is learn time memory move. Memory move, like I just see, when you convert the string to the bytes and just bytes to the string, it will call this this learn time function. So we can okay. So based on this result, we can improve our buffer. So we just return the strings, but we reuse our buffer, because preview every time our buffer is a new param. Every time learn this function, I will create this buffer. So I want to reuse this buffer. So based on this, I will pass this buffer from outside, from the benchmark. So every time I will reset this one. So based on this, the bench buffer, I will use the global buffer. So every time I will reset it, and then I will use this function. So let's see the result. So we can see buffer is much better now. So this is funny for all of our programming, because the performance is from the poor to the good. to the performance, the good performance. Like we just see the buffer, the first buffer is much poor and then improved a lot. It's much funny. I like it.
Simple improvements.
Yeah, but we can still improve this. We can still improve this result. So the first, this is because this is still return this string. So he still convert the bytes to the strings. So I don't want these strings. I just want the bytes. So the last we don't convert this. We just return these bytes. So the result we can see is much better now. Yeah. So I don't do the demo at the last. So the conclusion is this: if you use the string and the bytes, you reduce this converter. You convert the bytes lines to the string to the gun bytes. So if you can use the bytes, let's use the string, because inside the Go package, many packages use this bytes lines. They don't use the strings because why they should copy this one? Because in the definition of the Go, this is a dynamic. They can change this, but the string is a fixed, like the array. So they are different. So when you copy assign this slice to a string, he will copy this value to the string to a new array. So when you change this, he didn't change the orange data. So this is why this should be copied, this slice and the string. So the second thing, we reduce this converter, but sometimes we still need this. But in some, if you need to this, just use it. Never mind. Okay. So next time I will introduce the slice, array, and the map, which is a much better performance. So the slice is this. As you see, slice and array are different. Array is a fixed. So array like this is array. 5 element. So this is fixed. So this the slice have three elements. So one is a point to this array, and the second length, like this, how many elements in this slice, and the last one is the capacity. So how many elements can capture in this slice. So this is an example. So this is the array. So fix the element have the 10 elements. So this is the array. The slice, I use this slice from this 2. So from this element to the 5. So this is the first thing is the array pointed to this array. The slice pointed to this array, and then this is the length. So this length is 3. Why his cap is from this element to the end. So this is his capacity. So the slice and the array is different. Slice have up to 4. So let me show you this one. This is an array, have 3 elements, and this is slice from the 0 to the 2. So he have 2. His length is 2, and his cap is 3. The slice, and this is slice point to this array. So the first line we will print this. The array have 3 elements, 1, 2, 3, and this slice should have 2 elements, 1, 2, but his capacity is 3. So when we append a new element into this slice, 4, and then this array will change it, because the slice is pointed to this array. So when the slice changed, the array also changed. So now the array should be 1, 2, 4. And then the slice is also 1, 2, 4. And this is, at last, we want to append the slice 5 to this slice. But the slice's capacity is 3. He have no capacity to add a new element. So the length time will append the new array for this slice. And then this slice will change the point. So the array will never change, still 1, 2, 4. While the slice will change to 1, 2, 4, 5. Let's see the result. Yeah, just 1, 2, 3 for m, and then this is the slice, the init slice, and this is there's the same. Now after this append, the slice actually not point to this array. He already pointed to another array, but we can't get this one. Okay.
So now if I change the first value, it wouldn't affect the array, right?
First value?
I mean slice at 0th position, it wouldn't change the array value, right? They are two different copies now.
Yeah.
Array and slice.
Yes. Yeah. So the length time we will copy this array to another array, have the more capacity array. Yeah.
So I think like the key point is like append function, and all. I think most of the functions in Go like always returns a value, right? Not a reference or a pointer, right?
Yeah.
So that's
I will show you. So you just use the slice, never use the array.
that's the rule of thumb, right?
Yeah, because I will show you that slice performance is much better than the array. Because in the Go, all the paragon pass by value, not pass by the point. While the slice is point to the array, so he is passed by the point. But he has this pitfall. You should be careful. Yeah.
Is there any use case like of using an array? Have you encountered like an actual
But array when you pass, I will show you this one. So we will benchmark the reading from the array and the slice. So this is our array. So this is array. Array is different with slice is in this column. So array has the fixed size, while the slice have no this one. So here is slice. Yeah. So we have this init array, and this is the init slice. We init this all the array element and the slice element. So this is our array function. We read from this array, and this we read from this slice, and we will do this benchmark. From this result, we can see array have the poor performance. If we read the result from the array and read from the slice performance is much better than the array. Why? Because I just see the slice and the array in the Go, all the parameters passed by the value. So when you call this function, actually this array is a value copy. So when you call this function, actually this value is copying this parameter. So every time you call this one, every time is copy. While the slice is pointing to the basic array, so it's cheaper than this array. Yeah. So slice array. So we use the slice as much as you can. Yeah.
So it's still like it's pointer value. Like slice is not again like if you look at C, it's like you pass a reference, but in this case it's still a value, right? Yep. Even a slice, it's a value you are passing, a pointer value, right? It's the same. Yeah. It's kind of confusing. Like if you come from a C background, you expect like it's to be the pointer, but still it's a value, right? pointer value. Yeah.
Inside the slice, actually, it's a point. So next time I will compare the slice and the map. So we init this slice function. So this is our slice, and this is our slice init. So first I will compare slice init. When we create the slice, this is we don't know this slice length capacity. This is we create the slice with we know how many capacity should he have. So when you with this fixed size, it's much have the better performance. Well, because every time when you append this, this capacity will auto increase by the length time. While this you already know this fixed size, he don't need to extend this capacity. So if you know your slice capacity, when you should create this in the fixed size. But sometimes you don't know, you just use this.
But also guessing the value can be dangerous, right? If you exactly don't know the value. Over allocates the memory.
Yeah. So based on this slice and the slice cap, we can see this slice caps have the much better performance than the slice auto extender. Yeah. And the next time I will show this map init. The same. You don't. If we know the length and we don't know this length, every time create. So also map is auto extended. So based on this result, we can see the capacity have the much better performance. So based on all this result, the slice and the map, we can see the slice has the much better performance than the map, because inside in the Go, the map is a hash map. It's not like it's a hash map. So every time when you find this the key, he will do the hash and then find it in the bracket. While the slice is find this point and then I get it. So it's So the slice have the much better performance than the map. So then I will do the slice and the maps reader. Reader from the slice and reader from the map. And also the slice have the much better than the map, because I just see slice we just find the position, we can find it. While map you should do the key hash and then find this value. And at last I will show you how to use the goals inside the profile package to performance your HTTP website. You define your API server. You can import this one, and that's all. Yeah, and in your main goal, in your endpoint, the main.go, in your main package, you import this, and it will auto import the path for you. So when I import this, and then I will start my server in the localhost 8000, and then I will register this handle function. But actually, when you import this, it will run this package's init function. So he will auto register like the tools profile these routers for you, and every function inside he already do for you. So when you import this package, you already your server already have this performance package inside. So I will show when I run this it's already. So this is our server, yeah, and so we can easily use this function. So I can open this. But actually, you see, this router we didn't register it, but inside the profile package here already, we can see this here, and we can see now we have 7 Go routine running in my programming. So every Go routine is do something. So based on this result, we can easily see this one. The first Go routine is waiting something, waiting the Go routine. So the second Go routine do something, and then every Go routine do some one. You can easily see when your your program is on live. You can easily use this. Can see on live program. Maybe you have 1,000 Go routine on live, but and then you can know which Go routine is exhausted and which is blocked. So based on, and then now we because we have no blocks, but when you're on live, you can see these are how many blocks and the heap, and you can see how many memory and how the heap and then everything. You can see this one, and then the thread create how many thread he created. Yes, and for you can see all these things, and also we can easily, because we already online this, we can use this Go tool to get this CPU profile. So we can easily use this Go tool profile, and this is our server's address, and this is it will output the CPU profile to this one. So from this command we can get all the as the first it's the same as this one, the test the CPU profile. So but the result is come from the Weber. Yeah. So when I learn this one, and then I will do the.
You have to go to.
Oh. This. So then I will do the benchmark on this result, and then now he is recording all the program is doing. So this is it's finished. So based on this is the result based on our our benchmark. This is the result on our servers. So based on this result, you can. So, because now we are easily on this result, it's easily printer return this result. So we have no high point on this program. If we write some whole program, it will your program should have. You can find this high pointer in which line. Okay, I will show you again. Still do this. So this is my tools WRK. So do the benchmark. It's easy to do this. And this command is record the CPU profile. Now it's finished. So the default timeout record time is 30 seconds. 30 seconds. I think still have nothing. We can't see anything on this one. Okay. So this is and then we can also use this heap profile and the blocking profile. We can use this Go tools to do your profile. Yeah, that's all. Thank you.
Question. Like the tool that you use to launch concurrent requests to the server, is it like public WRK?
WRK, yeah.
Is it something that you have written?
This is WRK. You want to see what? So this is our program. This is the request every second.
Is it installed? Right?
Is it your program?
Is it
your
your
project or public?
Is it a public open source?
No, it's a open source. It's a open source. It's a famous benchmark tools. You can find it in Google. WRK. It's easy and it's much better than the AB. Yeah.
Did you the pproc thing? Have you used it in live to see how many teams and stuff you guys are running?
What? Online?
Have you used it in production? The profile tool?
Yeah.
Does it affect performance?
Yes. Actually, I use the Beego. So inside the Beego, I already have this tools inside the Beego. So based on this, on the Beego, I can easily record every performance record and something.
Or you can use
And
your own
also,
AB,
in our
modify your AB testing tool to like inject it only to some users.
in our program, we use the new relay. So
New
we
relay,
know
yeah.
the go routine, the memory, and the same thing we have the monitor in this one. So when the
New relay.
new relay.
New relay. So you can send any data. It's basically
Yes, and then I can see how many memories, how many go routine now.
Does it have like Go specific support or just general memory usage, right? CPU and memory?
I use the runtime memory status,
Okay.
so we can get all the things.
Okay.
Yeah.
Can we get Zalora discounts? No kidding. What about Go Max Procs?
Go Max Pro.
Max, there's
Max
a
Pro.
parameter, right? Go Max processor, MAXPROCS.
Yeah.
How does that impact performance? What's the value you set for that?
I always use runtime CPU name CPU. I forget this function.
Is how many
So for CPUs for?
user threads?
Yeah, I think I use the CPU time.
So if you got 32, you'll say 32. Or something like that.
No, I just use the CPU time.
But only when you run Go routine, then it will affect. Otherwise, if you run a single
So
routine,
this is
then
the
it
you don't see this.
It's free. It's memory.
So I use this function to return the name CPU, and then I will set this in the max port. You mean this one? Set.
Go Max Procs.
No, max.
somewhere
Up over there. You just scroll up.
Yeah, I got that.
Oh, that's little
All
further.
Max.
Go Max
Max.
Procs. Further up. Oh,
This
There you
one?
go.
Yes. So this I will set the Go Max Pros. This value I will get from name CPU. Yes.
Okay.
Any other questions? Right. Any other right?
Okay. Thank you.